Good day, ladies and gentlemen. My name is Majd Al-Muntaser, and I'm delighted to welcome you to this seminar video where I'll be sharing the results of my journey through modules 1 to 6 for practicum. Throughout this course, we explored various fundamental concepts and principles in electrical engineering, and today I'll present my understanding and experiences with each module, from tackling obstacles in series and parallel connections to delving into the fascinating world of electric waves. We'll embark on a creative and informative journey together. So without further ado, let's dive into Module 1 and unlock the mysteries of electrical circuits. So as you see here, we will start with Module 1, which is the obstacles. The obstacles is basically when we calculate the equivalent resistance, whether it's in series as this figure here, or whether it's in parallel as picture here. So when the resistances are in series, we calculate them by adding them together. For example, here we have R1, R2, R3, R4, and R5. We give them a value, for example, 5, 3, 7, 10, and 12. In order to find the equivalent resistance in the series connection, we multiply them together and we get the final result. And when it comes to the parallel connection, it's different here, because the rule goes like this. If we want to find the equivalent resistance in a parallel connection, we need to add the inverse resistance of each one. So that means we will calculate 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. And after of this, we will get 1 over R. And after we get in 1 over R, we're going to reverse it in order to get the R, which is the equivalent resistance. As we see here, we give them specific values and we calculate them, and then we reverse it in order to get the equivalent resistance. And here is another example, like R1 equals 8, R2 equals 1, R3 equals 5, R4 equals 11, and R5 equals 15. In order to find the equivalent resistance in series connection, we add them together, we get the result 40, for example. And in order to find the equivalent resistance in parallel connection, we do the add it together, we add the reverse, then we reverse it again in order to find the equivalent resistance. And these are more examples of this. And now here, and this circuit has like parallel connections and series connections at the same time. So how do we do them? We calculate them like manually. We start to look for the easy ones. Like for example, here we have R1, R2, R3, R4, R5, R6, and R7. We give each of them value. We start to analyze the circuit in order to make it in a simpler form. So we have, for example, here R3 and R4 are clearly in a parallel connection. So we calculate them by adding the reverse of each other, like here, 1 over R3 plus 1 over R4 equals 1 over R. And for this 1 over R, we reverse it again in order to get a new R, which we call now R8. And after that, we're going to add R2 plus R8 plus R5 in series connection. And after that, we're going to calculate the rest of the circuit, whether it's parallel or series connection, as we explained before. And here are some other examples that we explained in our practicum report. And that was this about the obstacles for series and parallel connections. Second one is Module 2, Ohm's law. In Ohm's law states that the voltage equals the current times the resistance. So in this circuit, we have here the voltage, and we need to find it using the resistance and the current. How do we do this? By simply multiplying the current times the resistance. Like for example, here we have I equals 0.48 and R equals 2. So multiply them, you get 0.96, which is the voltage. Another example, you could change the values and you could multiply them together and you will get the voltage and so on. And here are other examples. And now in module 3, we get Kirchhoff's law. In Kirchhoff's law, we find it like we add the whole voltages in order to get the voltage, the total voltage. So we have here V1 and V2 and V3. Each one of them has their own value, like we call them VR1. This is called VR1. This is VR2. This is VR2. VR1 equals 2 volts. VR2 equals 4 volts. VR3 equals 6 volts. The V total, which is the total of them, we calculate them by adding everything. It will be 2 plus 4 plus 6 equals 12 volts. And here, when they are in series, the current stays the same. So we get I1 equals I2 equals I3, which is here 0.20 amperes. And for R1 and R2 and R3, we could find them by doing the calculations here using Ohm's law. And here are some other examples that explain this or apply this rule as well. And here we have Kirchhoff's law on parallel connection. Now here in Kirchhoff's law in parallel connection, here comes another. The voltages are the same while the currents are different. So we have IR1, which is this, IR2, IR3, IR1 equals 1.6 amperes, IR2 equals 0.8 amperes, IR3 equals 0.53 amperes. These are just examples. And to find the I total, you can simply add them together in order to find it. And in order to find the resistance, you could simply use Ohm's law in order to find it, which is V equals R times I, or R equals V over I. And here are other examples with different values that apply the same rule. And now here we come to module 4, to the capacitor, series, and parallel connections. And the capacitors, when they are in series, they do the exact opposite of the resistance in series. And here we do them by adding the reverse of each capacitor. Like we got C1, C2, C3, and C4 and C5. Each one has a value, 5, 10, 3, 8, and 2. In order to find the equivalent capacitance, we need to add the reverse of each of them, and then we have to reverse the number we got here in order to find the equivalent resistance, as the example shown below. And if you want to do it for the parallel connections, in the parallel connections, it's for the capacitors, it's the exact same thing when it comes to the resistance in series. How do you find it? You simply add all the capacitors together. So if you got C1 is 2, 3, 4, 5, and 6, you could add them together and you will get the equivalent resistance, the equivalent capacitor easily. And here are some few examples from the results we got from our practicum. Here's the series, and here's the series parallel connection. It's the same thing when we did with the resistance. You have to calculate them manually. You look for the simple things like here, C3 and C4 are in parallel, and because they're capacitors in parallel connections, you have only to add them together. After that, you will get C2 plus C here plus C5 in series. Then you will calculate them in series connection and then you will apply the rule when you add the reverse of each capacitor in order to find the equivalent capacitor here, and then you continue this series or this thing until you get the final result. And these are some examples. And for module 5 is the transformer. How it works, like number 1, make a circuit like the experimental design drawing. 2, measure the primary and secondary voltages for different input voltages. 3, swap the secondary coil with the primary coil, then take measurements as in step 2, which is this. Here the picture of output 12, picture output 15, with the results here and there. And we have picture output 18. And here we have this table where we have the source voltage for the AC, which is here the same, and the current here is the same. 1 ampere. The voltage output is different, and the scalable is different from each one. In module 6, we have the electric waves, which is the last thing. And a measurement, we could use it for a measurement for sinus wave, how to find it, how to find or calculate these things. Known, for example, the F measurable equals 1 Hertz. Calculated parameters, we calculate them the period T equals 1 over F. And if you got F, you could simply find T, like for this example. And the frequency equals the reverse of the time or the period. So F equals 1 over T, which gives you 1 Hertz in this example. And long wave, like you might have been given it in the example. And the speed V equals lambda times G, and lambda equals 2.5 times 1, which gives us the speed. We could use it for different examples, like here frequent input 100 Hertz. You could calculate it, add them together as the example below. And these are some examples of this module 6. So as we conclude this seminar video, I hope you have gained valuable insights into the intriguing realm of electrical engineering. We embarked on a thrilling adventure through modules 1 to 6, exploring the intricacies of series and parallel connections on obstacles, Ohm's law, Kirchhoff's law, capacitor connections, transformers, and electric waves. We have witnessed the practical applications of these concepts, shared our experience, and tackled challenges along the way. Remember, the knowledge gained for this practicum is just the beginning of your journey in this valid field. Continue to explore, experiment, and push the boundaries of your understanding. I would like to express my deepest gratitude to everyone who joined me in this virtual expedition. Thank you for your attention and for being part of this incredible learning experience. Should you have any further questions or seek more information, please don't hesitate to reach me out. Stay curious, stay inspired, and may your future endeavors in electrical engineering be electrifying. Thank you and farewell.